Good morning to all of you. I welcomes to all in our lecture series on electromagnetic theory, that is your core paper 13, belongs to your 6th semester. In our last class we have been discussed about electromagnetic wave equations in terms of E and H. By considering the Maxwell's equation in this form, we derived wave equations in charge free conducting medium or for a conducting medium generally, and we found this expression, which is your wave equation in terms of electric field intensity. Then we found this expression, which is called as your wave equation in terms of magnetic field intensity. And if we are going to consider charge free conducting medium, charge free non conducting medium, or for a perfect dielectric medium, then we found the wave equation is in the form of this one. Equation number 5 and equation number 6 belongs to electric field and magnetic field. Now whenever we are going to consider the free space, then the wave equation we found del square E equal to mu 0 epsilon 0 del square E by del t square, or it can be written as del square E minus mu 0 epsilon 0 del square E by del t square equal to 0. Likewise, in terms of magnetic field, it can be written as del square H equal to mu 0 epsilon 0 del square H by del t square, or del square H minus mu 0 epsilon 0 del square H by del t square equal to 0. So these are two wave equations, or EM, electromagnetic wave equation, in the free space. So whenever we calculated by comparing with the general wave equation, we found the velocity of the electromagnetic wave is 3 into 10 to the power 8 meter per second. Actually, in the last class I mistakenly written it is C, but you have to write it is S, meter per second, which is the speed of the light. From this, it has been concluded that light is also electromagnetic wave having the velocity 3 into 10 to the power 8. In our today class, we are going to be discuss about plane waves in dielectric medium. Here dielectric medium means we have been considered the free space. Okay. Suppose a electromagnetic wave is propagating along z axis. This is your z axis, this is your x axis, this is your y axis. The electromagnetic wave is propagating along z axis, having electric field component along y axis and magnetic field component along x axis, and the amplitude of electric field, let it is E0, and for magnetic field it is H0, and both are perpendicular with each other, both the components, and propagating along z axis. So from the figure we can found that there is no component along z axis, only along z axis it is propagating, but electric field component along x axis, y axis, we found from this figure, and along x axis magnetic field. Okay, the same thing it has been written. Consider a electromagnetic plane wave propagating along z direction in free space. It is written in the bracket, in free space, whose electric field component vibrates. That means its electric components vibrates along y axis direction, and magnetic field, that is your H component, vibrates along x axis direction. That means electric component variation we can found along y axis only, and along x axis we can found variation of magnetic field only. A direction as shown in figure 1. This is your figure 1. So E0 mod H0 mod are amplitudes of electric and magnetic components of EM wave. Okay. So previously, that means in your second semester, whenever I taught you the optics, second semester, you can check your note. We know that if a wave, actually this is the plane wave, okay, wave propagating is propagating with a velocity v and its vibration is along y-axis. This is the representation. If a wave propagating along x-axis and vibration we can found along y-axis which is shown in the figure 2, then its differential equation is del square y by del x square minus with a velocity v. Okay, suppose it is moving along x-axis with a velocity v, minus 1 by v square del square y by del t square equal to 0. Let it is your equation number 1. These things we have been already studied in our second semester. No need to derive. You can check your note and you can found this equation, derivation of this equation. And the solution at the time we found of this equation is y equal to a sine omega t minus kx. Here a is the amplitude of the wave, omega is your angular frequency, and k is your 2 pi by lambda is nothing but your wave number. Here omega is 2 pi by time period, 2 pi by t, which is your angular frequency. Now by considering equation number 1, which is your this one, equation number 1, and the wave equations of 7 and 8 of 2 times I have been written, wave equations in bracket 7 and 8 of previous section. Previous section means here we this motion of this EM wave considered as in free space. So we have to consider 7 and 8 because 7 and 8 equations represents the wave equation in free space. This is nothing but del square E minus mu 0 epsilon 0 del square E by del t square equal to 0 and del square H minus mu 0 epsilon 0 del square H by del t square equal to 0. This two equation and equation number 1. Equation number 1, if we are going to be consider these three equations, the wave equations 7 and 8 of previous section, sorry, here by considering the equations here, the equations 1 and 7 and 8 of previous section, the wave equation only you have to write, the wave equation of electric field in free space as shown in figure 1. So as shown in figure 1, this is the electric field, wave equation of electric field only. So here see, this is the wave equation which is vibrating along y-axis, propagating along z-axis, and its solution is a sine omega t minus kx, and its differential equation is del square y by del x square minus 1 by v square del square y by del t square equal to 0. Here vibration direction is here del square y divided by del x square. That means x is represents the propagation direction. So here if you are going to consider the electric field vibration along y-axis but propagation along z-axis. So hence by comparing equation number 1 and previous 7 and 8 equation, then for this case, for this figure, the electric field vibration or electric field propagation can be represented with the differential equation as del square Ey by del z square minus mu 0 epsilon 0 del square Ey by del t square equal to 0. See, this is the general equation in 3D format. Del square E, here E means all the three components contents in this electric vector. But if we are going to consider this figure, here electric field only along y direction. Along y direction it has the vibration and z direction it has the propagation. So how we can write? It can be written as del square Ey by del z square minus mu 0 epsilon 0 del square Ey by del t square equal to 0. Again I am going to explain, you just watch. Whenever we are going to consider this figure and its differential equation, this is del square y, this is y means vibrational direction, by del x square, x means propagation direction, minus 1 by v square means velocity, del square y by del t square. Now if we are going to write the differential equation of this electric field vibration and propagation, then what we are going to write here? Del square y means component of electric field, that is ey, del square ey, this same thing it has been written, del square ey by, here propagation direction x it has been written. So here in this figure propagation direction is z, so we have to write by del z square minus mu 0 epsilon 0 is nothing but your 1 by v square, sorry v square, mu 0 epsilon 0 is nothing but v square, because here we have been studied that 1 by v square is nothing but mu 0 epsilon 0. So instead of 1 by v square, we can write epsilon mu 0 epsilon 0, then del square ey by del t square equal to 0. Let it is your equation number 2. So only for that this lines has been written that by considering equation number 1 and 7 and 8 of previous section, the wave equation of electric field in free space as shown in figure 1 will be del square ey by del z square minus mu 0 epsilon 0. Mu 0 epsilon 0 means 1 by v square. Okay, del square ey by del t square equal to 0. Let it is your equation number 2. Hence the solution of this equation number 2 can be written as what can be we can write here. The solution of this differential equation is, second order differential equation is, y equal to amplitude sine of omega t minus k is the wave number into x. Here x is direction of propagation. So in the same format we have to write, that will be ey, solution of this second order differential equation will be ey equal to e0 is the amplitude sine omega t minus k into direction of propagation, that is your z. Let it is your equation number 3, and this is nothing but your solution of the electric field of the electromagnetic wave which is propagating along z axis and having the electric component along y axis only. Likewise, for magnetic field we can write similarly the wave equation of magnetic field in free space as shown in figure 1 will be, how we can write, del square hx, because magnetic field component we can found in this case only along x axis. So it will be del square hx by del z square minus mu 0 epsilon 0 del square hx by del t square equal to 0. Let it is your equation number 4, and hence the solution of this equation number 4 will be hx equal to amplitude h0 sine omega t minus k into propagation direction z. Let it is your equation number 5. So this is the all about the representation or the dynamics, representation of the dynamics of electric field component and magnetic field component. So the dynamics will be represented always a differential equation, that is this one. This is nothing but the mathematical representation of the dynamics of or change of electric field with respect to time and z. With respect to time and z, what is the changes or dynamics for this case is written here, and the solution of this equation differential equation is this one. Similarly, the dynamics of the magnetic component is represented by this second order differential equation, and its corresponding solution is this one. So here these two solutions 3 and 5 represents at a particular time and a particular place what is the instantaneous displacement along y-axis for electric component, along x-axis for magnetic component. That means we can say This 3 and 5 is representation of wave or the so-called plane wave of a propagation of electric field and magnetic field. Okay, so next we have to move for the relation between E, magnitude of E and magnitude of H in a uniform plane wave, or we have to prove that magnitude of E by H, or the ratio between both the magnitudes, electric component magnitude and magnetic component magnitude, will be equal to 377 ohm or 120 pi ohm. Okay, these things we are going to be proof. How we are going to be proof? Let's start here. Consider a plane electromagnetic. Consider a plane electromagnetic wave, EM wave, propagating along Z direction, where electric and magnetic field components are directed along X and Y axis uh, respectively. Again, direction no need to write, respectively, as shown in figure 1 in your previous section. Previous section means I given one new heading, means the previous discussion is the previous section that I am telling. Okay, so here the previous section means here the figure 1 in the previous figure 1 of this section. Okay, so hence EY for that propagation of EM wave, EY is represented as E0 sine omega t minus kz. Let it is your equation number 1 for this section. Okay. But from Maxwell's third equation, we know that del cross E equal to minus mu 0 del H by del T. Let it is your equation number 2 for the free space. Okay, these discussions we are doing in the free space. Okay, accordingly you can consider the other dielectric medium. So here del cross E equal to minus mu 0 del H by del T is your third Maxwell's equation. You can check your note here. Third equation is nothing but del cross E equal to minus mu del E by del T for any medium. For free space, it will be mu 0 del H by del T. Okay. Now, so that implies minus mu 0 del H by del T. Here vector symbol should be there. Vector symbol del H by del T will be equal to del cross E. We are going to find out the del cross E. Del cross E is nothing but ax, ay, az. See here, ax, ay, az is the unit vectors of along x-axis, y-axis, z-axis. Okay, you can remember that any vector can be represented as suppose we have to consider any vector. This vector is represented by I cap ax plus j cap ay plus k cap az, like this. But here in your EM electromagnetic theory explanations, whatever we are doing, many books they are written in case of I cap, they are written ax, x, ay plus az, az. So instead of I cap, they have been written ax. So don't be confused. So here ax represents the direction. So ax, ay, az. Del cross E we are trying to find out. So del by del x, del by del y, del by del z. The component of E along x-axis Ex, along y-axis Uy, along z-axis Ez. So x, ay, az is equal to del x, del by del x, del by del y, del by del z. Here in the figure 1, whatever we considered, in that figure, electric field has only y direction vibrations, and electric components we cannot found along x-axis and z-axis. So corresponding electric components Ex will be 0, Ez will be 0, only Ey component will be there. Now we are going to do the cross product here. Carefully you have to watch. Ax means this row and this column we have to cancel, and this will be like this. del by del y of this one minus del by del z of this one. So like this we are going to do going to find out the first term. So ax into uh, del by del y of this one 0 minus del by del z of ey. So we can found only minus del ey by del z. Then minus ay. This is plus minus ay means if we are going to consider minus ay, this row and this column we are not going to be considered, then we have to consider this one, del by del x of this one, del by del z of this one. So obviously it will be 0, so I written minus ay into 0. Then az, if we are going to consider, then it will be plus this column and this row not to be considered, and then it will be del by del x of ey minus del by del y of 0. So obviously it will be plus az, this will be del by del x of ey, del by del x of ey. So that implies, this is vector, that implies minus mu 0 del h by del t will be equal to this much. That implies minus mu 0 del by del t of, now I am going to write this vector in this format, hx ax plus hy ay plus hz az. So the vector, it is written in this format, whatever I explained over here. Okay. So h vector will be represented as ax hx like this. Okay. So here this hx is the magnitude. Okay. So along x-axis, along y-axis, along z-axis respectively, is equal to this will be, first term will be minus ax del y del ey by del z, and this will be 0, and this will be plus az del ey by del x. Okay, so that implies minus mu 0 del by del t of this much is equal to minus ax. Here you can see that del ey by del z component we are going to be consider, this component we are going to consider, and this component will be 0, because ey, if we are going to consider ey in the equation number 1, then it is only the function of z. Okay, so hence del by del x of ey will be equal to 0. Okay, so this component will be vanish, so we can found only minus ax del by del z of ey. Ey is nothing but your e0 sine omega t minus kz. You just put over here e0 sine omega t minus, this is kz. Okay, carefully you have to write, this is kz. Okay, here I written from equation number 1. Now minus mu 0 del by del t of hx ax plus hy ay plus hz az will be equal to the first derivative of this one with respect to z. If we are going to do, then it previously it was minus, so with respect to z means it will be minus k, already minus is there, so plus ax k e0 cos omega t minus kz. Okay, so derivative of this one with respect to z will be cos e0 cos omega t minus kz into minus k. Minus k, here minus is there, so plus k. So ax into k e0 cos omega t minus kz. Okay, now we are going to be compare the components of x component of left hand side equal to x component of right hand side. Here only we can get only the x component only. Y component, z component we are not going to be found whenever we are going to compare all the components of LHS and RHS. So same thing it has been written there. Now equating or comparing, now equating the respective components of LHS and RHS, we get what? That is your minus mu 0 del by del t of hx will be equal to k e0 cos omega t minus kz, because other components are not found in the RHS. So hence it is written as minus mu 0 del h by del t equal to k E0 cos omega t minus kz. Let it is your equation number 3a. This is written as 3a. Okay, and minus mu 0 del h by del t component, if we are going to be equate, it will be 0, and minus mu 0 del hz by del t will be equal to 0. Let it is both these two considered as equation number 3b. Now we have to integrate the equation number 3a with respect to time. What we are going to get, you just integrate this one with respect to time. That will be minus mu 0 integration over del hx by del t into dt equal to k E0 integration over cos omega t minus kz dt. So here del t dt got cancelled, and integration of this corresponding derivative we can found hx. So minus mu 0 hx is equal to here you can found cos omega t minus kz dt. If we are going to integrate cos theta, integration is not, will be sin theta only. So cos a theta integration will be sin a theta by a. So here with respect to dt, whenever we are going to integrate, here dt is there, omega t is there. So it will be sin omega t minus kz divided by omega. So we found plus, this is plus sign, k E0 by omega sin omega t minus kz we found after integration. So hence that implies here it can be written as mu 0 hx equal to this minus gone this side minus k by y, k by omega into E0 sin omega t minus kz is nothing but your Ey that we defined in your equation number 1. Let this is your equation number 4. So let this is your equation number 4. Here k is nothing but your 2 pi by lambda and omega is nothing but 2 pi by t, already previously I written. You just write once again, no problem. So we have to just put over here mu 0 hx equal to minus 2 pi by lambda by 2 pi by t into Ey. Hx will be equal to minus, this is minus, okay, 1 by mu 0 into 2 pi got cancelled, t is gone to the numerator, so t by lambda into Ey. Okay, so hx will be equal to minus 1 by mu 0 into 1 by, it can be written as t by lambda can be written as 1 by lambda by t into Ey is equal to minus mu 1 by mu 0 into 1 by v0. That means here v0 is nothing but velocity of EM wave, whatever we have been considered. Okay, velocity of EM wave along z-axis direction, v0 into Ey. Okay, here you just we have to write here just here v0 is the velocity of EM wave, you just write. Okay, here v0 represents velocity of EM wave. So that implies hx will be equal to minus 1 by mu 0 into, we know that 1 by v0 or 1 by velocity, 1 by v square, sorry, we know that 1 by v square is nothing but mu 0 epsilon 0. So 1 by v is nothing but mu 0 epsilon 0 root over. So here instead of v we have been considered that v0 is the velocity of electromagnetic wave. So hence 1 by v0, instead of 1 by v0 we can write mu 0 epsilon 0 root over. So minus 1 by mu 0, 1 by v0 can be written as mu 0 root over of mu 0 epsilon 0, mu 0 into epsilon 0 into Ey. Okay, here I written because v0 is nothing but 1 by mu 0 epsilon 0 root over. So that implies hx will be equal to mu 0, here 1 mu 0 root over of mu 0 got cancelled, we can found minus epsilon 0 by mu 0 whole root over into Ey, or we can write that Ey by hx equal to minus mu 0 by epsilon 0. Let it is your equation number 5. Okay, now similarly we can found by considering, similarly we can found Ex by hx equal to mu 0 by epsilon 0 whole root over. Here you just see Ey by hx we found minus mu 0 by epsilon 0 root over. I just reverse the components, that is ex by hy. Ex by hy equal to mu 0 by epsilon 0 root over. That means for this derivation, whatever we are done now, here we consider that the electric component is along y-axis and magnetic component along x-axis. Suppose we have to consider magnetic component along y-axis and electric component along x-axis. Okay, if we are going to consider in this way, that electric component along y-axis and magnetic component along electric component along x-axis and magnetic component along y-axis, just reverse if we are going to consider, then we can found ex by hy will be equal to mu 0 by epsilon 0 root over. Okay, here previously we considered that the electric field along y-axis, magnetic field along x-axis, so we found minus mu 0 by epsilon 0 root over. If we are going to consider the reverse, then we can found this one plus mu 0 by epsilon 0 root over. Here we have to write, okay, you just write in this bracket. Okay, similarly we can found in bracket by considering electric field component along x-axis and magnetic field component along y-axis of EM wave. Up to this much you have to put the bracket from here to here. Okay, here to here, then we can found this much ex by hy equal to plus mu 0 epsilon 0 root over. How it is? You can check by rough. Here I am going to be do for you. You just watch. Shortly I am going to do for you that ex by hy will be equal to, how it will be, mu 0 by epsilon 0 root over. So for our previous derivation, we have been considered that electric field vibration along y-axis. So the solution of this electric field is represented by Ey equal to E0 sine omega t minus kz. Similarly, if we have to consider the electric field component vibrated along x-axis, then the solution will be written in the form of Ex equal to E0 sine omega t minus kz. Okay. Now we have to consider this one, del cross E. Del cross E, if we are going to consider, then this is your del cross E. We are going to be consider del cross E. Then what it will be, that it will be ax, ay, az, del by del x, del by del y, del by del z. Ex component will we have only ex component. Y component of electric field, it will be 0. Y component of z component of electric field is 0. So 0 0 I have been substituted, but previously we have only y component, x component, z component we have been substituted as 0 0. But here along x-axis it has the component y, z is 0 and 0. Now you just do the cross product. So left hand side will be same as usual. See, that is minus mu del h by del t. It will be written in the form of minus mu del by del t of this one. I have been written here, minus mu del by del t of hx, ax, hy, ay, hz, az. Here ax is represented the direction. Here it is not the value. Okay, it is the unit vector. You just consider ax is the direction, unit vector along x-axis. So now in the right hand side, the curl of this E, if we are going to be evaluate, you just see your ax, if we are going to consider, then this del by del y of 0, del by del z of 0, so 0. Okay, ay, that means your minus ay will be equal to how much? Minus ay means this row and this column we have to be restricted, and this will be del by del x of 0 minus del by del x of 0 minus del by del z of ex. So 0 minus del by del x, this is del by del x of, del by del z of ex. Got my point? Minus ay restricted this column and this row, the multiplication will be del like this. We have to consider the 4 like, okay, this like this. This is this way we have to multiply. Del by del x of 0 will be 0, del by del z of ex minus del by del z of ex minus del by del z of ex, and plus az of restricted this column and row. We found that del by del x of 0, del by del y of ex will be 0, because ex has only z, function of z. So del by del y of this one, del by del y of this one will be 0. So directly I have been cancelled out, I not written. So 0 0, the two terms ay and az terms will be 0. Now this will be minus and minus, it will be plus ay del by del z of ex. Ay del by del z of ex is nothing but our e0. This is sine, okay, e0 sine omega t minus kz. So you just put here e0 sine omega t minus kz, and first derivative with respect to z of this one is nothing but minus k. So it will be minus ay k e0 cos omega t minus kz. Okay, so now we are going to be compare the x, y, z components of left hand side and right hand side. We can found only y component in the RHS. So we have to equate only y component of LHS. The y component of LHS will be minus mu 0 del by del t of hy. Okay, so minus mu 0 minus mu 0, here I not written, this will be minus mu 0 del by del t of hy is equal to sorry, I here before one step it is there. So it will be minus mu 0 del by del t of hy is equal to, yes, actually this was correct. This was correct. So minus mu 0 del by del t of hy will be equal to y component. Y component means minus it will be I not written, minus ky e0 cos omega t minus kz. Okay, minus k e0 cos omega t minus kz. Okay, so here the left hand side is the y component is minus mu 0 del by del t of hy minus mu 0 del by del t of hy is equal to, only right hand side we have only the y component, that is on minus k e0 cos omega t minus kz, or here minus got cancel. After integration you can found that it will be mu 0 integration with respect to t, mu 0 hy, this side it will be k e0 by omega sine omega t minus kz. So by integrating this with respect to t, we can found mu 0 h equal to k e0 by omega sine omega t minus kz, or that implies mu 0 hy equal to k by omega ex, or you can found that ex by hy will be equal to mu 0 by epsilon 0 root of 1. So in this way we can prove that ex by hy will be mu 0 by epsilon 0 root over plus mu 0 by root plus whole root over of mu 0 by epsilon 0. So no need to write these things in your note, you just keep in your mind. You can practice in your rough for this, no need to write the these things in your note here. I just explained, you just watch, no need to write. So similarly we can found by considering electric field component along x-axis and magnetic field component along y-axis of EM wave, that is Ex by Hy equal to mu 0 by epsilon 0 root over. So similarly, so hence in general we can write the magnitude of E vector by magnitude of H vector will be mu 0 by epsilon 0 whole root over. Okay, so we have to put the value of mu 0 is 4 pi into 10 to the minus 7 by epsilon 0 value 8.85 into 10 to the minus 12, which will be equal to, or approximately you can calculate by your calculator, you can found approximately 377 ohm. So hence proved that magnitude of electric component by magnitude of magnetic component will be equal to at any particular time, uh, or at a particular instant, it will be 377 ohm. Okay, so here the unit is one type of resistance, also it is called as the impedance. Okay, impedance or resistance, that we are going to be discuss in our next class. So we found one type of resistance unit, and with a value whenever we are going to consider the ratio of magnitude of electric field by ratio of magnitude of magnetic field of a electromagnetic wave is approximately 377 ohm. Okay, now next, come to the next section, that here we have to prove another interesting thing, that E and H of electromagnetic wave being perpendicular with each other always. That means we have to prove that E dot H equal to 0. If both are perpendicular, so obviously dot product of these two vector will be 0, which is represented in figure 1. This is perpendicular, okay, this is perpendicular, this is perpendicular. So draw this figure perfectly. Okay, so we have to prove that E dot H equal to 0. That means E and H both are E component by electric component and magnetic component of a electromagnetic wave always perpendicular with each other. How we are going to prove? E can be written as AX, EX, AY, EY plus AZ, EZ dot AX, HX plus AY, HY plus AZ, HZ. So after doing the dot product, we can found this will be Ex Hx plus Ey Hy plus Ez Hz. Okay, so whatever we have been here for this derivation, or for this considerations of your E and H propagation, that is your considering the figure 1, whatever we have been represented here. Okay, that means this derivation is refers to this figure, that means electric component along y-axis and magnetic field along x-axis. So same thing I have been written shortly, that Ex Hx plus Ey Hy plus this is 0, because we have been considered for this case is as wave, as EM wave propagating along z direction. So when the electromagnetic wave will be propagated along z direction, hence Ez and Hz component we could not found along z direction. So Ez equal to Hz equal to 0. Okay. So let this is your equation number 1. And previously we found that Ey by Hx equal to minus mu by epsilon 0 root over Ex by Hy is equal to mu 0 by epsilon 0 root over. Now from this we can found Ey equal to minus mu 0 by epsilon 0 root over into Hx, and Ex equal to mu 0 by epsilon 0 root over into Hy. Let this is your equation number 2 and this is your equation number 3. Now we have to substitute 2 and 3 in equation number 1. What we are going to found? We can found that E dot H equal to mu 0 by epsilon 0 whole root over into Hy Hx plus minus mu 0 by epsilon 0 whole root over Hx into Hy. So both are same but opposite sign. Got cancelled, we found 0. So hence proved that E and H are always perpendicular with each other. Here we consider that the wave is propagating along z direction. So along z direction means there is no component we can found no component of electric field and magnetic field we can found along z direction. So Ez Hz equal to 0. That means if we are going to draw the figure for this corresponding derivation will be this one. Okay. So here we have to stop our discussion today. You go through this video properly, pause the video and write down the note perfectly. And in the next class we are going to be discuss about pointing theorem and pointing vector. Pointing vector is represented by p, is the vector symbol. Next class we are going to discuss this one. So thank you so much for watching this video. Thank you. You write down the note perfectly. If you got any doubt you can ask me. Thank you.